everyone. Today I will discuss the problem D, entry and escape from Capygrad, which was from the yesterday's Codeforces round 892. Okay, so we have been given a city named as Capygrad, which is the capital of Tiago land, where some incident has occurred, and that's why entry has to escape from that city as far as possible. And we have been given some portals. Okay, so entry has to escape the city using these portals only. So Tiago land is represented by a number line, and the city of Capygrad is located at point 0. Okay, there are n portals all over Tiago land, each of which is characterized by four integers. Okay, so basically the portals are represented by some segment li, ri, ai, and bi. I will discuss it later. Note that the segment ai and bi is contained in the segment li, ri. Basically, the portal is represented as, suppose it is li, then it is ai, then it is bi, and it is ri. So basically, the segment AI comma BI always lies within the segment LIRI. Okay. So if Andre is on the segment LI comma RI, then the portal can teleport him to any point on the segment AIBI. Basically, what it is saying is that if suppose the Andre is at any point in this segment, means with segment LI to RI, then he can teleport to any point within this segment. Okay, ai to bi, the portal, using that portal Andre can pass, then the portal can teleport him to any point on the segment ai comma bi. So that's all about the question. Andre has a pass that allow him to use the portal an unlimited number of times, so he can use the portals uh, as many times as possible. Now, Andrey thinks that the point x is on the segment L, comma R if the inequality x greater than equals to L less than equals to R is satisfied. So it is quite obvious that if the point x is on the segment L to R, so it should lie within the range L to R. Okay. So Andre has Q options from where to start his escape. So we have been given some Q points now. We can say Q queries, where in each query you will be given an integer xi. So we have to consider that the Andre will start the initially at this point, means at point xi, and now we have been asked how far he can go from this xi point using the portals. Okay, help him to determine how far he could escape from the Capygrad starting at each of the Q positions. Okay, so that's what I have said. No, now let's move on to the input pattern. We have been given t test cases, the number of test cases, then the number of portals, and each portal is united by li, ri, ai, and bi, the characteristics of the portals. And then we have been given q positions, basically q queries, and for each query, suppose we have been given a position, the starting position of the entry, the position from where the entry will start his escape, that has been given in each of the queries. So uh, yeah, let's discuss the test cases itself. Basically, let's consider the first example. So we have been given this. These three are the portals. So if I represent, so one, and then I can say 1 8, sorry, it would be 3. Better to discuss it here on itself. So it has been given. So L1 and R1 was this. So where is L1? It is 6, and R1 is 17. R1 is 17. R1 is 17. Then we have been given 1 12 3 and 8. 1 12 3 and 8. L2 has been given 1 3, and B2 is 8, and R2 is 12. Okay. 7 and 14. I forgot to. A1 was 7, and it was 14. B1. Okay, and now 16, 24, 20, 22. So 16, 20, 22, and 24. That's all about the mapping. Let's say now let's start our escape. Suppose the starting position was 10. Basically 6 is the number of queries, and now for each of the query I have to answer the how far he can go from the given position, starting position. Suppose the starting position was 10, so where does the 10 lies? You can see the 10 lie in both of these. So I can say, suppose let's start from here. If 10 is here, then obviously since is this segment, it has been stated that using the portal, the portal can teleport him to any point on the segment AI, BI. It has been stated, no? So the portal can teleport him to any point on the segment AI to BI. So using this, I can move to the segment 3, 8. But will it be beneficial? Obviously not. 10 is obviously greater than 3, 8. But wait, there is another portal. Okay, so through this portal, the 10 will lies here. Okay, so obviously I can 10 lies between the 6 comma 17, so I can teleport to BI itself, so 14. So this is the maximum I can go. You can see the 14. Now let's discuss for 2. 2 lies here. 2 lies here. So obviously I can go to uh, B2 because this is the maximum possible. So B2 is now 8, and the position is now 8. Okay, the position is now 8. But one thing again, 8 again lies in this segment 6 to 17, and using this portal, I can go to 14 again, 14 again. But if I just move to the 14, I can't go further because the next segment start from 16. So basically 16 doesn't 14 doesn't comes in this segment. That's why I can't go further. That's why for 2 also this 14 would be my answer. Okay, now for consider 23. 23, it is 23. 23 lies here. So what I can say, that I can move on using this portal, I can move to this segment. But will it be beneficial? Obviously not, because 22 is less than 23. So better to not go to, not to use this portal. Okay, so 23 would remain the answer. Now, just let's consider 15. So 15 lies in this segment. 15 lies in this segment. So one thing you should know, that the 15, fif- if I just use this portal, then I can the maximum I can move is to 14. But obviously 15 is greater than 14, so I will not use this portal. And also 15 doesn't lie in any other segments. Just you see, 15 doesn't lie in this segment 16 to 24. So 15 would remain 15, I can say. You can see here 15. Now let's again discuss 28. So obviously 28 again doesn't lie in any of the segments, so 28 would remain 28. And 18, let's consider 18. So now here comes the now 18 lies in this segment, so maximum I can go to 22. Maximum I can go to 22 using the portal, as it has been stated that if the point lies in Li to Ri, then I can move to AI to BI. This is the AI to BI. This is AI to BI. That is 20 to 22. So I can say that I can move to 22 maximum. So that's all about the question, and let's discuss the approach using which I have solved the problem. So we have been given this test case. So the first portal is this. First portal is this. Better to take. Now, uh, one thing you should observe, suppose this is a range we have been given. I will just transform this problem into a simpler one that you will be able to solve in on yourself. Okay, suppose if L1 and then A1, B1, and it is R1, and again another portal is L2, B2, sorry A2, B2, and R2. So now what I can say that I will just prove that this R1 and R2 are of no use. Why I am saying so? Why I am saying so? Because suppose if if a point lies here, so obviously now suppose if a point lies here, so obviously there doesn't make sense to use this portal. Okay, so I can say that this portal will be useful for all the points which are only in this range. Okay, and the maximum which I can move to using this portal is b1. Okay, b1. So I can say that a1 is also of no use. Why? Because if suppose there is any point in this range, so obviously I can move to b1 itself. Okay, but if the point is greater than b1, if the point is greater than b1, then I have already told you that using this portal, the what where I can move to this segment. But will it be will it be helpful? Obviously the point which lies, suppose it is x here, it would be greater than b1, so it doesn't make sense. But why I am saying that r1 is of no use? Because if x lies on another segment, lies on another segment, so obviously suppose if x doesn't lies on, x was something somewhere here, means greater than b1, and now I have to prove that this portal will be for of no use for x. Okay, how I can prove that? Obviously we know that according to the definition that all the points which lies in this segment can be teleported to this segment a1 to b1. So obviously x is greater than b1, so why would I just use this portal? So obviously I would have to use another portal. And suppose if x lies in some other, suppose if x lies in some other segment, l2, e2, b2, and r2. So I can say that if a X lies somewhere here in other segments, so obviously this portal will take it to the required point. No, so obviously I can just skip it R1. Why? Because if some suppose if no, so I was that X lies somewhere in this segment, in this portal. So suppose if there doesn't exist any other portal in which x lies, so obviously x would remain x. We have already seen while discussing the problem. And if suppose if there is another there exists a segment where x can lies, so obviously I can prove that I can say that this portal will be of no use, because obviously I cannot increment x using this portal, because the maximum it can be teleported between a1 to b1. So obviously this portal will be of no use for x1, for x. And if I say that uh, any portal will be helpful for this x if x lies in some other segment, means if x lies in some other portal. So in this way I can prove that this r1 will be of no use, means the points will be which are greater than b1 and less than r1 will be of no use, means this portal will be of no use for that points. Okay, so I have proved that. So my idea lies in the same, in this concept itself. Now what I will do is that I will just transform what I have said, that a1 is also of no use and r1 is also of no use. So suppose the the portal is like this: a, b, and r. I can just transform this to l to b, meaning that all the points which lies between L to B obviously can be teleported to B maximum, and also if it is greater than B, then this portal will be of no use for them. That's what I mean to say. So now I can just transform this. Just remember this, how I have just transformed this portal to a segment. Okay, so now my segment would become, I can say L was 6 here, and then uh, L, R, A and B. So A was also of no use. Now 14. It will become 14. 6 to 14. I can transform this to this. Now this can be transformed to 1 comma 1 comma 8, and this can be transformed to 16 comma 16 comma 20 22. Now just recall the concept that if you are now asked any point, if you are given a point x and you have been asked how maximum you can go using these intervals, so will you not be able to say this? Obviously, I will just sort this. I will just sort all these segments 6 to 14 and 16 to 22. And now one thing you can recall, just suppose if I have, what I can do is that now I can just merge this. Why? Because I can just prove that all the points in this range can be teleported to the maximum 14. All the points within these two segments can be teleported to the 14 itself. So I can just, why I am saying so, that because one segment was 1 comma 8. Okay, 1 comma 8, 1 comma 8, and another segment was 6 comma 14. So what I can say, that if it is a portal, so obviously I can teleport to any point. So I can teleport to maximum 14. And suppose if I am at this portal, okay, I am using this portal, so maximum I can go to 8. So if I go to it, so again 8 lies in this portal, so again I can go to 14. That's why I said you that I will just merge them, means all the portals which can be merged I will just merge them. And now the resultant would be this. So I hope that you are clear with why I am merging, because just consider this: if if the segments are like this 1 comma 8 and 6 comma 14, 6 comma 14, 6 comma 14. So if I am at this if I am at any point if I am at any point within this portal, then obviously I can go to 8. Okay, and if I go to 8, then obviously I can go to 14, because 8 lies in this portal. That's why better to just merge them. So it's better to say that all the points between 1 to 14 can be teleported to 14 maximum, and all the points between 16 to 22 can be teleported to 22 maximum. So that's the only thing you require, and now you can answer all the queries. Just say, if it is 10 lies in this, so answer would be 14. Answer would be 14 for this, because Now, if it is 2, so again answer will be 14. I can teleport it to 14. Now, if it is 23, I can teleport it to. I cannot use the portal, so it will remain 23. Again for the 15, 15 again doesn't lies in any of the portals, so again I cannot use any portal, so it will remain 15. Now, for the 28, again it will remain 28, and for the 18, 18 lies in this portal, so I can teleport to 22. And if you see the, it was like this. So yeah, that's all about the approach. Let's move on to the solution. The main concept was just to derive this, that AI and RI is of no use. Okay, and that's what I have explained. And also the another concept was to merge them. Okay, so now let's move on to the solution. So I have already taken the input. So I would just first of all take n. N is the number of portals we have been given, and then I will take a vector of pairs which will store the resultant portals, means the only li and bi. Okay, I will just ignore the ai and ri, and I have already told you why I will ignore that. I will just store only l and b. That's what. And now I will just create another. I will just merge them. I have said, that I will just merge them. I have already explained. So now you would become merge intervals. Let's name it NB. Okay, let's create the merge interval. Obviously, it is a very standard question of merging intervals. I will just sort all the intervals. You will find this question on the lead code, also merge intervals like so. If you don't know, then you should first do that problem. S is the starting of the interval, E denotes the ending of the interval, and N is obviously A dot size. Now, what I will do is I will initialize a0 dot first, and E is equals to a0 dot second. Now, for int I is equals to 1, I less than n. If ai dot first is greater than ending, means the ending of the interval till now, so obviously I would have to start another interval from here. EV is the pushback, s comma e. Then now what I have said you, that I will start another interval from here itself, and now e will become e maximum of e comma ai dot second. Else e is equals to maximum of e comma ai dot second. Now finally I will return this answer. One thing I forgot, answer dot push by, because uh, obviously the last interval would remain to be pushed. So now I have got these sorted intervals, and only I require is to just process the queries. So suppose m is the new size of the portals I have received. So I have to take the queries c into q. Now for each of the queries, I will be given a position, and now what I will do, I will just use the binary search. Okay, I will use the binary search. Let me discuss how I will use. Suppose the position was 10, okay, and the segment are this. This is the sorted segment. This is the sorted segment 1 comma 14 and 16 comma 22. And suppose there is another segment, there would be another segment. Suppose 24 to 32. Okay. Now I will apply binary search, and what would I find that what would be the index of the segment in which the 10 would lie. Okay. So suppose if I just perform the binary search, mid is equals to 0 plus 2 by y2, because here 0 based indexing, n is equals to 3 here, 3 segments are there. So the last index would be 2. So if I just perform, I would just get I would arrive at this segment. So how I will check that 10 is lying in this node. So if 10 is less than, if 10 is less than the first element of the segment, so obviously I would just move to the left part. And if it suppose it is greater than the, suppose if it is greater than the last element, so obviously I would have to move to the right element. So in this way I would just uh, check in which index, what will be the index of the segment in which the particular element would lie. And if for checking, suppose now I have moved to the left, why? Because 10 is obviously less than 16, so I would have to see in the left part. So now I just arrived at this segment. So 10 lies between 1 and 14. So this would be my required index. So the required index would be 0. And now what I will do, the answer would be the 14 itself. I have already explained that I can move to the, using this portal, I can move to the maximum 14. Okay. So I hope I have discussed. Let IL is equals to 0, high is equals to m minus 1. I have already said index is equals to m. So you just know that if suppose there doesn't exist any segment, so that element would remain the same as it was previously. That's why, to indicate that, I have just initialize index is equals to m. And now mid, while low is less than equals to high, while low is less than equals to high, mid is equals to low plus high minus low by 2. Now I would check if it lies is in segment or not. Mid dot first, and x is less than equals to v of mid dot second. So it lies in this segment. So I would just break. Index equals to mid and break. If it is not so, if it is not so, if x is greater than, if x is greater than v of mid dot second, means it is greater than the last element. It is greater than the last element. So I will just have to move to the means I will just have to try a segment which start with maximum greater element than the segment we are at present. So I will just move to the right. I have said, I have explained, no, else, else if x is less than b of mid dot first, means if it is even less than the starting of that segment, so obviously I would have to try a segment having minimum elements. Okay, so I would just move to the left part. So yeah, that's all about. So if now I will check if n is equals to m. So in that case, I have not found any portal which can be used for this position. So I would, the answer would remain the same as x. Else, what I can say, it would be v of index dot second is the ending of that portal. I can maximum reach to that location. So that's all about the code. Let's run it. You can see it has been passed. So that's all about the problem. Thanks for watching.